The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another volcano update, Hawaiian volcano update today, Thursday, June 17th, 2021. We will cover both Maunaloa and Kīlauea, and our topic today, for the most part, is earthquakes. And a lot of you guys here, residents of Hawaii Island, may have just felt the magnitude 4.5 that happened a little more than half an hour ago. We'll talk about that. We'll also talk about what's happening in both volcanoes with the patterns of earthquakes and the other monitoring signals, courtesy of the USGS Hawaiian Volcano Observatory as well. We will take a break and discuss our viewer questions in between talking about Kīlauea and Maunaloa, and then again after Maunaloa, and of course I'm sure the earthquake questions will come in regardless continually, so keep them coming. We'll answer what we can in the chat. Dane will be taking care of that while I narrate our update today. And so let us know if you have any issues with our streams as well, and Dane will be monitoring that on the chats as well. All right, so we'll start off today with showing you guys this one of the more recent images of Kīlauea summit. This is within the caldera, the summit pit crater of Hale filled with that crusted lava lake now, right? And just to remind you guys, it's just solid on the outside, and there's still a big liquid glob inside of that pastry, so to speak, right? Of that big lava crusted cone shaped lava lake that's filling that former collapse pit. So the lava is still intercooling. It's going to be doing that for the rest of our lives, or until something else comes and disturbs it, which may happen sooner than later, perhaps. So that is just the view today at the summit. In fact, I want to say this is earlier this week, maybe June 11th or so. So let's turn to the earthquake first. This is the most recent USGS earthquakes page, reloading it here. And here is our summit, our island of Hawaii seismicity. And what you see is these red dots here in the bottom part. Let me zoom in a little bit. That's the recent zone of activity, including the magnitude 4.5, which is highlighted right there. That just occurred at 4:32 local time here in Hawaii. So let me get my pen here. Circle this region for you guys right in here. So that's the deep root of the seismicity here on Hawaii Island. And we have shallower seismicity both on Kīlauea over here and on Maunaloa that we'll talk about today. And it kind of goes all the way down to there, in fact. But since everyone is likely on social media to see what that earthquake was all about, let's look at it first. There it is at 4.5. And you maybe can't see it here. I'll read it for you guys. The depth of this is 32.7 kilometers noted down here. And that's in the range of maybe 20 some miles, 23, 25 miles. I didn't do the math, somewhere in there by estimate. And you can see that there have been several aftershocks in that same area, all these other red markers right in there. So I'm going to circle them once again. The reds in this particular map are within the last hour, orange within the last day, and yellow within the last week is what we're looking at here. So you can see that there actually has been a 3.1 that occurred 15 minutes ago, a 2.0 just before that, 1.9, 2.3, 2.4, 2.0, and these are all, well, the exception is 2.4. 2.4 is at 2.6 kilometers deep, so that's above that whole area. All these other ones are down in this 30-kilometer depth range. And that's what really matters, is that these are in that lower regime near where we believe the hotspot's interacting with the island. So I'm just going to scroll down, and you can see, if you guys can see this in a bigger screen, all these are all in a 30-kilometer range here. Once in a while you get one of these, magnitude 2, that's above here, adjusting above it. Okay. So what is going on there? I pulled up this image, and I have to look up the paper it's from here, but this is one sketch of a asthenosphere-lithosphere boundary below the Hawaiian island chain. And those are big words. Lithosphere just means the area of the Earth here that's behaving as a solid. Lithos, like a rock. And the part below that, the asthenosphere, is just the part that's behaving like a fluid flowing, right, with ductile movement. So it's thought that the hotspot comes and somewhat deflects here because this whole lithosphere above it is moving to the northwest here as part of the tectonic plate. And so above this zone of hotspot, you have this interaction where these two red arrows are indicating the path of magma that's being generated coming up towards the islands. And this is important mostly because of the scale over here on the right. If you look, this is 0, 50, 100 kilometers down. This is the whole depth of the whole lithosphere. So when we're saying we're down to 30 kilometers, we're not upper half still, but we're still in that solid rock way down there. And for better clarity, here's another image that we've brought up before. We've discussed this with Brian Shiro of the USGS, and this is from a paper by Wes Thalen, I believe. So here on the left at the top is the actual earthquakes with little dots, and they've colored them different type of events. And down here is interpretation on this bottom part of the panel here. And so maybe I'll zoom it in a little bit. It might be hard for you guys to see there. All right, so 20 kilometers down, 40 kilometers down, 60 kilometers down, right? So we have areas where we have tremor that's maybe slightly deeper than where we are there. But this zone of 30 kilometers down is a well-known lineation here, right? That is part of the structure of the volcano. Okay. You can see the interpretation down here. This is part of that mantle fault zone that's proposed here in this publication that perhaps connects this deep tremor and mantle plume area over to the east towards Kīlauea. Kīlauea is over here in the top right. All this shallower stuff, these blue ones, that's just the shallower structure of Kīlauea right up in here. And so we're talking about much deeper than that and off to the side. And so it's still a big question of how this mantle fault zone might possibly connect to magma. And there's a big question mark through there. And of course, we have some older versions of these images that show our Hawaiian volcanoes like Maunaloa here. And schematically, the mantle generation, the mantle magma source straight down from there, and at depths ranging from 60 kilometers to 40 to 30 kilometers down, as far as this magma source region being fairly deep, and then rising up through the more solid crust. So of course the crust has to be solid for it to generate an earthquake to actually break and release energy and spread it across the island for us all to feel as that jolt. And that's happening here in this upper part, like at the sides, right? So somewhere in this regime here. And of course, we did have a recent Volcano Watch article that talked about how perhaps because of increased magma movement into this area, there may be collection points, perhaps, right, that might be maybe flaring off and causing earthquakes to have a signal that pushes upwards as well as outwards. To recap that Volcano Watch from perhaps 3-4 weeks ago now. So that's the long and short of the Pāhala earthquakes. We've talked about these before. I don't necessarily have to rehash everything in great detail, but I just wanted to recap for those of you guys who maybe haven't seen that information or joining us more recently and curious what happened today.
We do have one comment that was kind of interesting from Jennifer, who was saying that it basically happened right under her house, the epicenter of the earthquake. She says, quote, "The most intense part of the shaking lasted over 2 minutes. And then the smaller shaking continued for 7 more minutes," end quote. Which is interesting, you know?
Yeah, so that's smaller.
Right there and it being that deep.
Right. Yeah, it's interesting. Yeah, it's interesting to wonder about that smaller tremor lasting 7 minutes, if that was actually perhaps some other movement of tremor or some aspect of that earthquake, rolling waves or whatever. So that's really interesting for it to last that long. It's definitely an interesting, weird event. It seemed kind of big for it being a deep Pāhala earthquake, right?
That was my first thoughts. Was that's a big one for Pāhala, for those deep Pāhala ones, and it also is at that slightly less depth. I mean, normally we're looking at 40 kilometers. 32 is right in the ballpark, but it's starting to get closer to what the depths we'd expect on the path to Kīlauea. Right, because once we start seeing from Pāhala to Kīlauea, we see a little bit of a shallowing in there. It was one of those styles, so it was really interesting, just that depth and that big.
Yeah, absolutely. Yeah, so that's our excitement of the afternoon here, and it's a good segue since we're going to talk about earthquakes and other volcanoes the rest of the time as well. But I'm sure that there is one more question about this earthquake that, if it hasn't hit the airwaves, will hit so soon. Did it change anything on the volcano? Is always what people want to know. So let's start moving through some of the photographs, and I'll go through just only a couple from this past week here of images of the summit of Kīlauea. So looking at June 3rd, UAS drone view of the west vent here. You can see quite a bit of collapse in this western part, but no other. You really can't see a whole lot of fume coming off of there. You don't see any glow. Interesting. After view. I'm sorry, I can probably click on it and you can zoom in quite a bit there. You can see what that vent looks like a little more up close. All right, so that's the one view on the UAS, and the other view of the UAS that was released was looking straight down the neck of that vent, looking for glow. And if you look closely here, and absolutely nothing in there. Obviously it's still hot, but it's just not hot enough to be glowing, or there's something blocking that hot zone from the view that we have into this pit here. So that was June 3rd, and let's catch us up here. I showed you guys the one from June 11th, and that's really it. So we'll look at the F1 thermal camera here, and this is updated just around 5 o'clock. Let me refresh it here so we can get the most current information and show you guys. So refreshed at 5:08 p.m. Hawaiian time, and no change in there really. You see there's still a few hot spots, areas that are appearing as brighter colors in the surroundings here. But there's still temperatures. If we were to look on the scale here on the right, the top of our scale is at 160 Celsius. That's well below lava temperatures, as the USGS keeps stating in their weekly updates here. So it's still hotter. Little cracks and the underhangs and the ledges and those places is where that heat's remaining there. And no change that we can see. Here's the last 24 hours time lapse. Not a lot of change there either. So moving on to the KW camera, the visible camera, no glow at night. Some completely dark camera view, the visible range here. And then otherwise, still some fume coming off the crater walls on the sides and a little bit here on the south side as well. And you do see some fume in a west vent in this view a little bit more, but not nearly as much as it was before. So no obvious change there. We can put this one back and reel it to we'll go through this exercise here since we just had a interesting earthquake. So there's let's zoom this out. From 5:11 p.m. 10 minutes ago, and no sign of any change there. A little bit of a rainy, foggy day at the summit today. Localized here. S1 camera. Let's reload this one too. And this one we don't get an automatic time lapse, but we do see the view here post 5 p.m. looking down into the pit from the south, and no change there as well. Don't expect change, of course, but I want to go through these photographs anyways and just show you guys. Looking from the east, B1, a little bit more of that fog, but you see that crusted surface, the west vents here at the back. Yeah, someone pointed out this might be maybe a nice big smiley face here, so you guys could see what you see in there. These are the first little islets that hardened and crusted in this whole eastern part of the lava lake over here. And you see quite a bit of gas coming up here on the right side still. And that's really all the visuals we have. And so we're going to turn to some of the data and the earthquakes. Let's start with a USGS text update here. Let's make this thing a little bigger so that someone can possibly read it if you like. But essentially, not a whole lot of change. We have SO2 rates are still down. 70 tons per day is the most recent measurement, June 11th. They're saying one deflation-inflation cycle over the past week, mild inflation. And they're saying seismicity stable overall. So otherwise, no surface activity. Rim and local cavities are visible in the thermal imagery, and otherwise no real change in the update. No real change in the East Rift Zone update. It does still note that the summit to the upper East Rift Zone area between all the way to Pool is still refilling with magma. That's something that we're going to see evidence of here. And so it's still noted. That's not a change, but it's been doing it at different rates. And that is really what we're going to cover there on the text update today. So let's go through it more visually, since that is our medium here. And this is SO2 for the last month. Our scale here on the left in tons per day goes from 20 to 180. That's 160 tons range. And you see the variation over the last month here going this way. So we've had as high as 160 not quite a month ago. For the most part, ever since the beginning of June, especially right here, but back to perhaps the last few days of May, we've been in this range of between 70 tons per day and 50 tons per day, right in there. That's more or less our range there, and that's our normal background. That's a little bit higher than we saw when there was a water lake in Halemaumau Summit. So that's all falls in line, it all makes sense. And to put things in context, here is our last year. So we are down here on the zero end, back similar to what we were beforehand. And really the spike was that December 20th in particular, through perhaps the 26th, 27th, in that range in there. That real spike of SO2. And of course, these values over here were still high and generating lots of fog and bad air for people downwind, ocean view, like Jennifer, guys in South Kona, all the way up in North Kona for a good part of the time as well. But now we're back in this background level here. That's the context of our SO2 rates. So looking at the depth of the lava lake, measured by laser rangefinder here, Here, meters on the left, 229 meters, 225. So the biggest change was still last week, what we talked about last week, this 3-meter drop. That is likely that crustal subsidence of that lava lake. And really, it's interesting that since then, there doesn't seem to be a whole lot of change. I mean, there's a lot of variation, right? But it's basically flatline there. So we seem like we're very slightly coming down, and then we drop down, and then we flatlined there. So no real change here on that. And to show you guys a little better, let's zoom it in here. This is just the past week. So you see there's an oscillation, which may have to do with measuring conditions or some other factor that we're not aware of here. But you can see there that perhaps this baseline, it's hard to tell exactly where, but it seems to stay like it stays fairly steady through there within the resolution of our instrument anyways. And once again, put it in context, here's that whole eruption. The continuous laser rangefinder has been automatically measuring in blue here since early January, putting on this website. And before that, it was then manually and put in here in green. So you can see that the lava lake got really deep very quickly. Something like 50% of the whole volume was erupted in the first 5 days, and the other 50% in the following 5 months. So really, most of the work done here in that first 5 days, first week, and then coming up slower and slower and slower. And then finally here on the right, we've dipped down and flatlined. Zoom in a little bit there. So, and this week, Volcano Watch released just today by the USGS will be in a paper this weekend. Some background on that lava laser rangefinder that's pointing down into the pit, measuring the lava surface. And it was really important, among other things, for tracking eruption, calculating volumes as in real time as they went along, combined with the DEM information, but also to, at the end, suggest when the last injection of lava under the crust actually was, May 13th. So we did see that the lava on the surface was still red until May 23rd. But the last injection when we saw that crust rise was May 13th. So that may have actually been the end of the lava input and possibly overturning beyond that. So this article is great. Talks about a lot of the technical details here. So especially if we have any engineers in our audience, worth checking out some of the details here. Let's see, he's put in all the in-house fabrication for the housing that they've installed there to make this workable. And yeah, I'll leave it for you guys to check out on hawaiitracker.com. We'll get that up there later tonight, I believe. So moving on to the rest of Kīlauea data here, we'll look at deformation, and there is our tilt, ground tilt. And in the last 2 days, we're entering, and we're in the middle of a deflation-inflation cycle right now. We're in a deflation part, and always at some point it bottoms out and comes back up as an inflation. So we'll just wait for that to happen here in the next few days. And looking back at the past week, you can see that's what happened about a week ago, this deflation-inflation cycle. And here's our newest one we're coming into right now. We'll keep zooming out by scrolling down, and here we are at the past month of tilt. And now we're starting to see a tilt scale that's meaningful from positive 10 microradians to negative 10 microradians. This is 20 microradians in total. And while microradian is a small thing, when I start adding up, my personal unofficial threshold is somewhere around 5 microradians. If the signal is bigger than that, then it's, and especially within a short time frame, then it becomes more meaningful. So our time frame is pretty long here, looking at a whole month, but we are starting at -4 microradians and ending up here at somewhere around 8 microradians. So 12 microradians again over the month. That is a slow, mild inflationary rise. This is nothing alarming. This is not like we see prior to eruptions, where we might see this thing actually coming straight up or dropping straight down, depending which way the magma is moving near it. So I'll try to find perhaps for next week, or the week after, some of these old plots for comparison. But this rate of tilt we see here increasing is a mild rate of increase, and not alarming in its own. You can see we're still having the deflation-inflation pattern superimposed. Interesting, though, that we have one this past week. We're having one coming up this next week, apparently. We have one a week before that. Before that, we had 2 a week and 2 a week. So maybe slowing down, maybe not meaningful, but for those of you guys who are trying to think and use your mind as a quantum computer to figure out what's going on down there, there is some added information of the pattern there. Okay, we'll move down to the GPS. In the GPS, we're looking at the cross caldera distance here in the top graph, and meters over here on the left, and 1 year on the bottom on the right here. So as magma comes into the volcano, the distance spreads apart, and it goes up, and it goes up at a fairly high rate, or possibly faster, building to an eruption. This was the eruption relieving the pressure in those 5 days at the end of 2020 there. And really, after that transitional period has been on a rise. It was rising fairly quickly during the eruption while lava was still coming out, because presumably magma is coming into the system at depth faster than it was getting out at the surface. So you do see it still building up, sometimes faster. It seemed like it slowed down a bit in April, and perhaps has been sped up a bit in May. And really, in its last couple of weeks of June here, it looks like it may have sped up even more. It's getting to be a little bit steep there, right? It's not quite as steep as you see right in here when we had an intrusion, not quite as steep as right here when we were building towards that eruption, but it's getting there. And of course, there's noise in there, and there are other factors besides just how steep this is to indicate an eruption. But it's to the point where certainly it's on the docket that there could be some small breakout. And of course, the longer we wait for things to build up, then you could have a slightly bigger breakout in the areas that are showing that activity, which is in the national park, at the summit, and the Upper East Rift there.
It's important to note also that last week we were talking about, we can't use that one data point. It might be just noise or a little bit of inconsistency. We got to get a little bit more data. Well, here you go. A week later, and it's consistent. The data points that fell in the range.
Yeah, you can see that if you take any 3 or 4 day range, there is certainly a spread, right? But the spread keeps rising more and more and more and more. So that natural spread is still there, but it's definitely incrementing upwards there. So it's going, and it could do this for weeks to months. And of course, if it starts getting steeper, then you start knowing it's more likely days to weeks rather than weeks to months. So not quite there yet, and just by itself, without especially more seismicity. We are seeing seismicity, but just not quite enough yet. When we start seeing more seismicity and it starts turning upwards, then we can shift our expectation perhaps of some change, whether it's at the surface causing an eruption or underground and not causing an eruption, but something will have to change at some point when the pressure builds that much. And at that point, we can shift it from being weeks to months to perhaps days to weeks. And so right now, I'd still say weeks to months, right? But getting to the point where we consider looking for changes that might indicate it to be days to weeks. So that's the deformation at the summit. And of course, it's important to go down and look at what's happening on the East Rift Zone. And so this is the distance measurement at Pāhala. At the end of that segment that we believe is an open pathway of magma. And you can see that down here, it's still just like the summit. You see a spread of range. Sometimes that spread gets pretty big, right? You can see this. There's some times where there's quite a lot of noise there. So noisier perhaps than the summit, but you do see what looks like perhaps an increasing trend on average. It's hard to say exactly when there. If so, it's not very fast. It's definitely not alarming, right? So this is perhaps maybe the sign of the rift zone spreading a little bit if magma is reaching there. It's not reaching it in any very, very massive amounts. It's doing it just a little bit there. So for comparison, I'll scroll it back here, and a build up to the eruption last year, you see there was quite a bit of a steeper increase there as magma was filling in that area. And so you compare that steepness there to what we see here. It's maybe there's something going on, but it's not really quite happening yet. So we'll look for this signal to see if at some point this may steepen as well. And that would indicate a magma is reaching that area near Pu'o as well. So to investigate this a little further, we'll look at some of the other signals. First, we'll go through the tilt. Tilt at the summit is pretty normal. The station you saw at Wikahuna is representative of everywhere, so I won't spend any time on that. The rift zone is very tricky because we have escape road as kind of that connection between a summit and the east rift zone that's shown over here. So it looks like we have a movement here towards the south, which it's some version of magma moving from the summit to the east rift zone pathway there, causing this change. And I can't be more specific because this is a hard one to I haven't quite found the words to explain this one easily. So maybe someday. Over here, the POO station is noted as faulty. Only one component's coming through, so it's hard to know exactly how reliable that is. But perhaps you might notice, in this range here, it's kind of small. Maybe we can take the tops of this curves as somewhat an approximation. And maybe there's a slow rise. Nothing dramatic happening there. Nothing to worry about. The POC station, which we also wonder about its integrity, because occasionally you see drops that perhaps are localized settling that's closer to the station in the cone, which we know is crumbling and falling into itself. It's showing a slight increase as well. Nothing major, but nothing alarming, but there are sensors there, and if something major were to happen, you'd imagine that would overcome any of the inadequacies of the installations or of the data, and you'd see a pretty big signal. So not seeing any big signals anywhere in the rift zone. And of course, moving down past Pu'o to that lower east rift zone area, steady at Jonica, no obvious changes. Small scale to start, you see kind of an oscillating pattern. That may be something not magma related there. And so essentially that's what I'd call the background there at Jonica. So we'll skip the south flank and we'll move to GPS, and we'll look just at the rift zone once again. So southeast at Maunaloa, 5 miles from the summit. And you can see that this is how I've been thinking about it. You can see this east component's been it's been getting pushed to the east for a while, as magma was refilling that whole upper east rift zone area, right? Even during the eruption. And that switched recently to not getting pushed to the east anymore. Right? So perhaps that front of that pressure front of magma that might have moved past Maunaloa, perhaps somewhere in there. It's hard to say exactly because you don't see it really going up either, and you don't really see a whole lot of change here, just small wiggles in the north. So hard to tell if that's what's going on there exactly, but something changed. And it's not just there. You look at Kananoyohamo, you see that similar pattern right there as well, right? Kananoyohamo, 7 miles east of the summit, a couple miles east of Maunaloa. And looking at the north-south component there, which maybe indicates getting pushed from the rift zone direction, you see it was climbing here. Let's zoom in a little bit. And so we're looking at this middle component here. And January is there, so December falls right in here. So you can see this is the eruption time was right in there. So it was moving, as it was pressurizing, was moving to the north, right? That's the overall trend here. The eruption relieves it. It kind of steadied out. Magma started flowing back in, was reported by the USGS. Started going the opposite direction a little bit, and then now it's coming back up there, right? So it does appear like there is some flux of magma through there, and it's been obviously changing, but now it's moving in, and it appears like it's that this change right here at the top corresponds with that change here in the north. So it seems like based on this, the magma has also gotten to this Kananoyohamo area by Mako Apui, at least in enough volume to start changing several components there. If we look at Kīlauea it's still getting pushed from the west considerably, so maybe more of the pressure is west of there, and it hasn't quite, that inflection point hasn't quite come around, but it is also moving north right in there, up very slightly. So it looks like magma is still coming in there. We go to Pu'o, and Pu'o moving to the east, moving to the north a little bit, and not moving up. So you see that's the difference between these last two stations here. 11 and 12 miles east of the summit. The ones that are 5 and 7 miles east. So somewhere in there, the magma is moving into that upper east rift zone area, and it's we do believe, and based on a lot of historical studies, that this area of Kananoyohamo has a larger magma storage area similar to Pu'o'o, and that in fact even deflated during 2018. So it would make sense as well that it would take extra time to get between here and down here because you have more space to fill, especially right in that little segment of the Upper East Rift. Okay, so let's move on to more earthquake information here. So for the last year, you can see that in the last month, our rates have been elevated compared to the previous eruption time before that. And of course, prior to the eruption, we were elevated as well. Our baseline back then might have been somewhere in here with a couple buildups here. This is that the sequence of intrusion and then building to an eruption. That's this three-week period right in here in early December. And there was an adjustment at the Kauiki area between Maunaloa and Kīlauea that came in there as well, right? That we also see as an extraordinary adjustment, right? Something above and beyond the background baseline. So the background baseline being somewhere right around here. Maybe I'll call it 400 to make it easy, since that's a line of earthquakes per week here on the left. And you can see that for the last 4 weeks, we've been hovering around that same mark. So perhaps this will be a sustained era here of that 400 earthquakes per week across Kīlauea. And that kind of puts us in this background era, waiting for that next little spike to come as an indication of something building up towards popping out. So we are here, we're not here yet. And we're down here at this, right? And possibly slightly below that, depending on how you see it. Maybe it's tailing off a little bit there. So, but that's the range of why we'd be on slightly higher alert for Kīlauea of the two volcanoes between Kīlauea and Maunaloa right now. Here's the past month. So you can see there's that slightly higher over the past month, but you see a lot of variation as well all through there. I thought I'd show that one as well today. Okay, maps. Past month on Kīlauea is starting to build up seismicity in a summit, very easily to see there. Let's zoom this in. And so down here in blue is our Pāhala earthquakes, or deep earthquakes. That's what we talked about earlier. Up here is our summit region. This is our Upper East Rift connector right in here. You can see they're both seismically very active. And then our Upper East Rift area goes between Pu'o'o, which is over here, and Maunaloa, which is over here. This is our Upper East Rift area right in here. And you see there are earthquakes here as well. And below that, this is a south flank. And these are all the south flank earthquakes down in here, and of which the biggest events have been triggered over here in this area, where there was a 3.7 within this past week, following in that same location near where the 4.2 was previously, the 4.2, 3.6, 3.4. We'll look at that here shortly, but first let's show it to you guys for just the past week. So the past month is a little bit flooded. What's a little bit more current, and a little bit more current, you still see quite a bit of activity here in the summit, quite a bit in this Upper East Rift connector right in there. And you do see earthquakes over here in this Upper East Rift area as well, right? All the way to Pu'o'o. In fact, Pu'o'o is right over here. Notably, you don't see them anywhere over here. Nowhere over here on an East Rift zone, right? And that's another good sign that nothing is getting past there, right? And in fact, even this one little earthquake doesn't mean magma is getting to right there. It just means it's putting a pressure, and that's part of that crack system that's moving. Right? So this area of the south flank that's mobile, that's active here, you can kind of draw. It's most active, like right through there, kind of like that, right? So you imagine that as magma is working its way around this bend from the Upper East Rift connector into the Upper East Rift in here, that this area of the south flank is kind of like an accordion, and right now it's got room to give. So the magma is coming in here, and rather than setting off earthquakes only along this one region right in here, like is happening just uprift, you're able to distribute those earthquakes across the south flank by having the magma push it and push the south flank to the south, all through there, right? And so this thing is all earthquakes at the base of this big piece of rock that's moving, getting pushed by magma coming into it right in here. So the overall pattern is all consistent. We see signs of pressure of magma at the summit, pressure on the Upper East Rift connector, pressure in the Upper East Rift translating as well to the south flank segment that is right there nearest to the upper east rift, in fact. Right. You do see earthquakes further down the south flank, and that's in part because this is all one big feature. It's not necessarily extremely coherent, but when things on the over here to the west move, then eventually it can kind of work its way down, domino effect, and kind of start moving stuff here as well. And all that's good, that's normal. Of course, our concern would be if at some point that were to destabilize this rift zone and break the barrier that's over here, as it was a case of what happened in 2018. In that case, it took a 6.9, and so if something like that were to happen again, then of course all bets are off, but we're seeing the south flank moving and not building up towards a big earthquake, and it doesn't seem like that's what's going on. It seems like it's adjusting through small adjustments, an accordion with room to give still down here. So as of right now, no concern for anywhere outside of the national park going down rift here. So interesting earthquake pattern. This is Kīlauea active this week, and just wanted to point out here, there's that 3.7 that occurred on June 12th. And let me zoom it in here so I can show you guys. See that same pattern here, summit, upper east rift connector, and then dispersed south flank right in here. Right, it's looking just a bigger events. It's maybe a little bit cleaner pattern. And so right here on this western side, it seems to be perhaps one of the catch point for this block that's moving to the south here. So there's our 3.7. The 4.2 was right there. That was May 23rd. And also on May 23rd, before the 4.2, there was a 3.6 and a 3.4, both in that same area right in there as well. So all very close to each other, very similar depths. It's all that same catch point, more or less, and it seems to be associated with this whole piece of south flank over here that's trying to move to the south because the magma is injecting its way in this area right through here. So that's the earthquakes. We'll show one last view of it here and animate the last week here. Zoom it in here. So we're running for the last week or so, and you just see it's nothing super fast. It's not like it's like there are swarms of earthquakes popping off. That could be a next level that we get to at some point sooner than later, but there's no signs of that happening quite yet. So right now it's essentially an increased elevated background right there, what you're seeing. So that's Kīlauea, and then I'll zoom out here because after we take our break, we'll talk about Maunaloa. And there is a bit of an adjustment here on the south flank of Maunaloa, between Maunaloa and Kīlauea. And you can imagine that as the south flank of Kīlauea moves out of the way, right, and it gives room for the summit to spread, right, that this part of Maunaloa is like, oh, there's a little bit less push over there, let's move as well. So that's the pattern between both volcanoes this week is the south flank of Maunaloa is moving, and the south flank of Kīlauea is also moving, and more through earthquakes. And then, of course, we have our extra earthquake that happened about an hour ago now in Pāhala as well. So we'll take a break there, and we'll take some Kīlauea questions, some earthquake questions, and we're going to turn and cover Maunaloa here, hopefully fairly quickly at the end. But first, we will turn it over to Dane to say our thank yous and choose some questions.
Yeah, do want to thank all of our sponsors first and foremost. We are brought to you by viewers like you. I know you hear that from like PBS and stuff, but here it's really true. Your sharing of the videos, your likes, your subscriptions, your donations, they all play a huge part in keeping this production going, and we really appreciate all that help. We do take donations on hawaiitracker.com/support, but we'd really like to encourage you just to share this video into your social media accounts and get it out there a little bit more. That's really makes an impact. We also want to thank our sponsors, Kalani Tours, that does very personalized tours on the volcano, on the waterfalls of the Big Island, as well as some of the west side coffee farms in Kona. Really educational and informative tours compared to some of the what I'll call the big box tours, where it's just cram everybody into a big bus and then yell at them through a loudspeaker. And this is, that much more personalized experience really goes a long way to helping people understand a little bit of the dynamics here on the island, which makes it a truly unique place. Our second sponsor we want to shout out is Kīlauea's Bar and Grill in the heart of Pahoa. Really do some interesting twists on some traditional dishes as well as some local kind dishes as well. I eat there regularly, indoor, outdoor dining, full bar, really good customer service, great place to go for locals or for visitors. If you're in Pahoa visiting, really encourage you guys to go check them out and let them know that Hawaii Tracker sent you. Phil, do you want to shout out our grant before we go into questions?
Yeah, for sure. Yeah. So we're brought to you today in part by a grant from the Puna Strong Fund of the Hawaii Community Foundation in partnership with the County of Hawaii. And so we're really mahalo those guys, Hawaii Community Foundation, Puna Strong Program, County of Hawaii as well. And maybe this is as good a time as any to mention that we were at the Revitalize Puna event last week, and it was great to see the community coming together to work towards resilience as is our main mission as well.
Right, definitely. So yeah, we want to thank everybody, especially everybody that's made donations and subscribed, all that kind of stuff as well. We don't have that many questions to go through at this stage. We'll get to another question and answer segment later. Most of them are still right at about Pāhala, and a little bit of clarification there. The general question that I've seen, I'm just going to take Karen's here. It says, I'm concerned about Pāhala, any chance of an eruption in the near future?
Yeah, great question. It's interesting that we can consider this for the first time now, and I see that for the first time now because we don't see any evidence of a vent that comes from deep through the crust of the earth to the surface anywhere near Pāhala. Like, Maunaloa is already there, and it's already an open pathway. And generally speaking, we think it's easier for the magma to come up through that established pathway than to try to break its way through rock to make a new one, right? Especially if there's already a path up that's been channeling magma upwards towards the surface for millennia already, right? Why would you just suddenly change in 2021?
And the Lower East Rift Zone shows that the volcano can make bends. It doesn't have to go in a perfectly straight line. It can make some weird changes into where it goes and where it feeds. There is a statement that was just released by USGS, sorry. Ken Hahn, the scientist in charge, has a quote. I'll go ahead and read it for you. He says that, quote, "This earthquake is part of an ongoing seismic swarm under the Pāhala area, which started in August 2019. This earthquake has been the largest to date in the current swarm and was widely felt across the island of Hawaii and as far as Maui, Oahu, Kauai. Please be aware of aftershocks are possible and may be felt. HVO continues to monitor Hawaiian volcanoes for any changes." And so exactly basically what we were saying, these deep Pāhala earthquakes, part of that whole cluster and series of ongoing earthquakes down there. It's interesting that this is the biggest. I didn't have time to look that up, but it was kind of what the gut was saying is this was the big one for down there.
Yeah. Interesting. We will follow up on that further as well. But I mean, really, that's really what matters for people is can those earthquakes under Pāhala, which have been going on for a long time now, can that bring magma to the surface at Pāhala? And the answer really is, I mean, it's really anything is possible, but we've never seen it happen in geologic history in the lifetime of the island. That's at least that's recognized to this point. And we don't see the earthquakes working their way shallower. If it was going from 30 kilometers to 25 kilometers to 20 kilometers to 15 kilometers to 10 to 5 and working its way up in sequence, then that might be more alarming, right? Especially if you saw a swarm of them, then you might say, okay, it's actually found some crack to the surface. We don't really think that that's the shape of the land there. It actually works. It uses the pathways that are there to Kīlauea, to Maunaloa, to Loihi.
Definitely. The next question isn't about the volcano specifically, but Jimmy asks Thursday evening, and I didn't hear about this at all. Thursday evening around 8:30 p.m., NOAA and AC-130 Hercules flew low across fern forest up to Kīlauea measuring geomagnetic waves. Have you heard anything about that, or did you hear the plane go over?
I may have heard the aircraft go over, but I don't know of any results, and I'm not sure how and where those will be published. Right. Hopefully, it's USGS collaborating with those data collectors and comes out to the USGS at some point in time.
Right. My immediate gut reaction to that is, if it's the government that's doing research along something like that, don't expect an immediate release unless it's something, dangerous is happening or pressing or anything like that. If it's academic, then they're going to take their time with it and try and get it right, as opposed to, jumping at the thing.
Yeah, for sure. But what I can say, because, I appreciate Jimmy's question there, is we do know that the movement of magma, which is very iron rich in Hawaii, actually will induce a magnetic field. So it's possible, and it's been done before, that you can measure the disturbed magnetism in areas, let's say around a lava flow, or perhaps around a rift zone. I'm not sure, exactly. It would have to, where you could be to be able to measure that. You have to be very specific parameters of where you could be, but you actually can measure something about the volcano, and but probably you can't do it from an aircraft at the resolution that we would need for Kīlauea. It's probably a larger scale study, I'm imagining, than that.
Makes sense. We have a $20 super chat from Les, who says, "No mention necessary." Well, you're getting one anyway, bud. And thank you, guys. Thank you for the donation. We'll end up with one last question from Richard. He says, "Is it possible to know the pressure differential between inflation and deflation events?" That's there's a lot in the answer to that question, right? It's not exactly so. We don't exactly know is the easiest answer, right? But we do probabilistic models, Monte Carlo simulations, that give us confidence ranges for starters, the size of the magma chamber that could be generating such signals, right? That's one parameter you would need to get from the actual tilt of the ground to some more useful information like that. Yeah. So if you use the most likely probability ranges, for example, you could come up with some approximations of what those pressure differences might actually mean. But it can be so localized and geometry dependent, right? That really complicates things. So you can do a lot of models and say, well, it's consistent with this or with that or the other thing. But it's hard to know exactly, right? We're not even sure how big the chamber is. We're not sure exactly how those things are generated. We're not sure the geometry of the conduits that are generating them, right? It could be something that's a change in geometry rather than a change in flux, for example, as magma is moving through an area. And so we just don't know enough, is what I'm going with. You could start getting guessy about it, right, by using those simulations and those parameters and trying to go from there and making some assumptions, but it's a big can of worms, so I'll leave it at that. Right. Well, that'll do it for the first round of questions. We will be doing one more, so if you can get your questions in the chat, Facebook, YouTube, or even Twitter, we'll get them in.
All right, mahalo, Dane. Mahalo, you guys, for the questions. And so we'll turn now to our Maunaloa section. And I want to start off with a Maunaloa update from the USGS here, just because that is some of the only information that we have about the seismicity on this northeast flank. So let me zoom it in here a bit for you guys. So we're still at yellow, aviation code yellow alert advisory. That's tier 2 out of 4, right? That's what they define as elevated unrest, right? And so, you look at our activity summary, we're not erupting. Our seismicity is slightly elevated above long-term background levels. So we're just at the slightly range there. So, despite no changes in deformation rates or patterns that indicate increased hazard, there have been noted 195 earthquakes, small magnitude earthquakes, in the past week. 195. Last week was 60. The week before that was, I want to say the average for the past 3 weeks is about 50 or so. So we're now up almost at 200 earthquakes. And of those, only 46 are beneath the summit and upper elevation flanks. And for the last many weeks, all of them have been under the upper elevation flanks and summit. So now we're down to, less than half of them, close to a quarter of them only being in that summit region. And so 46 is not too different from the 60 we had last week. So on top of that, what we're doing is we're adding on 89 other ones under the southeast flank. Right in there, right? And so of course there's more, there's another 60 that belong elsewhere, right? But that's the meat of it right there. 89 earthquakes, small magnitude under the southeast flank, all less than magnitude 2.5. But noted here that bumps this number up to 195 for the first time in a while, right? So there was also noted the largest one was a 2.6. That was on the southwest flank, 2 miles down, and otherwise everything else is normal there as far as the update and unchanged. So let's look at that a little bit more detail. Here's our past week of maps near Maunaloa Summit. And there's really not a whole lot on here, right? So you look, and southeast flank would be this sector over here, and there's a lot of small dots in there. You maybe can't even see them unless I zoom it way in, but there's some small dots on there, and these might be some of those small magnitude earthquakes, but there must be a lot of them outside of this box, off to the side there, and maybe over here too, right? You don't really see them on here. And unfortunately, we don't get this size earthquakes plotted in all of our earthquake maps. So let's see if we can figure out where these earthquakes actually are. The northeast flank, so here, this might be some of them over here. You don't see a whole lot under the summit itself, right in here. It's pretty quiet right in there, right? A little bit on this northwest flank. So that's interesting. That usually flares off a little bit when magma's coming into these upper regions, middle to upper regions in there. So it's still active. Magma's still coming in the volcano, it seems like. It's hard to see as much here in this last week. And so if we go to the last month, now we can see perhaps a little bit better. We did have that 3.2 last week, fairly shallow, so that's a sign of shallow pressure as well, pressure moving to the shallows, even through some translation domino effect of it. But a little bit here in the northwest sector as well, and maybe over here is where that kind of cloud of the southeast. But really, if so, then these ones are in accounts for the previous weeks and not really adding a whole lot. So it's not really clear that's exactly what's adding up to all those earthquake numbers. The earthquake rates graph that we see from Maunaloa is based on that map, and if we look at that, you can see that there's really no big spike here. Earthquakes per week's on the left. And this is 50, 100, 150, 200. Right? So 200 should be right in here if it was all within that range of that map. So you can see that within the range of the map, it's only 50, and it's all the other 150 must be outside of that little square elsewhere on the flank of the volcano. Further down, closer to Kīlauea, is the most likely answer there. So here is the Maunaloa monitoring map on the USGS page, and looking at it a slightly different way. And let's see if I can get this to work here. So now we have the earthquakes colored by depth. Let's see if I can pop the legend up here. And here's our depth range. The maroon is above sea level, and red is down to 3 miles, orange down to 6 miles, yellow down to 9 miles, so on. Nope. So you see there's that little cluster in the northwest, and a few over here, right? Here you see some of these bigger ones. You don't see quite the same threshold of values, but there's a little bit here in the northeast flank between Maunaloa and Kīlauea, and also one right in there. So that's a 0.8. This one over here is a magnitude 2. That one is at 1.9. That one's at 1. That's what we're seeing there in Maunaloa. And over here in the southwest flank, this is that one mentioned in the update. That's a 2.6 right there. And there was also 1.8 that happened a couple days afterwards right there. Right, so that's interesting too. So let's look at that in a little more detail. We basically are seeing movement, not in great resolution here, but movement of the southeast flank over here. Right, maybe some pressure over here, and some movement of the flank over here as well. Right? And of course, down here, here's a pretty shallow one as well. This is maybe considered a flank earthquake, although now we're getting in at misses on a Pāhala. You see I've excluded the depth of Pāhala earthquakes on here. I took off all the deep ones. But sometimes that deep stuff does cause adjustments above it, right? It's just, as far as being worried about eruption, just having one above it isn't enough. You really want to see like a whole connected train of them moving upwards, which is not what this is. It's just a couple, one here and one there. So this one is likely an adjustment to that deeper stuff. Over here, it's in the border zone between possibly being the south flank moving and being an adjustment to that zone. So not quite clear there. Right, a little ambiguous. There's a lot of these border zones, right? Like right in here is that border zone of Kīlauea and Maunaloa is adjusting. So you both have Maunaloa southeast flank moving, but then also the adjustment between Kīlauea and Maunaloa happening in this lower Kauiki area. So let's look more at this southwest, because that's a little intriguing. We've not talked about that as much before. And here is a plot for of that area. Zoom it out there. So there's the flank of Maunaloa. This is we're looking right in here. And what I've done is I've plotted everything since the start of the year. So these are all the events since the start of the year. And I can show you guys that, there's been about, just right in this pocket right in here, is about 18 of them. Oh. Back here. So, and if I order it by magnitude, I can show you guys that back in January, there was a 3.2 down over here. There's a 3.1 over here. It's a 3. That was also January. The 3.0 was over here. That was in March. There was a 2.8 at the end of April up here. There's another 2.8. Where is that one? Right in here. That was that one was back in November. So really, it's been an average of about 3 per month since January is when this thing appears to have been moving. It's not moving very fast. 3 earthquakes per month, at least the ones showing up on this threshold, still isn't that many. But it's more than it was before. If I pull up what it was the previous year, here is a previous year, what it looked like. So that's 2020. And there's 2021. Let's see if I can get it lined up a little better here. 2020 and 2021. So there had been some earthquakes, maybe 13 or 14 through the whole year of 2020. And thus far, 2018, we're at 18 or 19 for the year, halfway through the year. So you can see that we're at least twice the rate, perhaps a little more locally right here. So it is moving faster than it was, even if it's not moving super fast in the grand scheme of things. All right, that's that west flank there. Excuse me. So I wanted to bring up this paper that was released in 2020, or was it released in 2021? 2020, I believe. Matosa, Okubo, and Shearer. So this is UCSB, Santa Barbara, and Scripps, and USGS, my old advisor at USGS, Paul Okubo. And I'm not going to go through the whole paper, but what this is basically doing is it's relocating all the seismicity from the entire island through 2020. So, for example, here, I'll zoom in a bit here. This is a before view at the top, the raw catalog before they go through and essentially cleaning it. What relocation means in earthquakes is sharpening the focus and improving it essentially by improving the quality of data. So you go from this to this, right? Uh-oh. Dane, you
had a little hiccup there.
Yeah.
Looks like you're back.
Okay. Good. So. Yeah,
it looks like we're still live too. It just looks like you dropped a bunch of packets there.
Yeah, a little power surge came through here. Yeah, okay. If we're on, then I will keep going here.
Yeah, we're good.
Looks like everything's good here. All right, thanks for checking. All right, so going from the relocated events down here, right? So when you look at the relocated events, you basically can see the patterns of where earthquakes actually happen. So I brought this up because I'm interested to show you guys what the pattern was like beforehand. So you see this South Kona area in here does have earthquakes. It's just not nearly the same amount, right? If you look at the southwest flank, the west flank of Maunaloa in general, not nearly as many earthquakes as the southeast flank. The southeast flank is the one that moves more. And there's a couple catch points right there. There's that Kīlauea area, that's the border of Kīlauea. You see these upper zones, and then lineation coming down all the way over here. And so those are the areas where the earthquakes have occurred for decades and decades and decades, essentially. And you can see that, this area over here is actually part of this Kīlauea fault zone, right, which is this western flank, Maunaloa, right through there. So it's not like they're happening somewhere totally random. That's an area that does move. It moves, when a volcano starts swelling enough, and we're seeing that a little bit now, and that's the story there. So that's a pattern. I won't spend any more time on that, besides to point out that it does exist here, and I'll come back to it at some point again.
Can you further expand real quick? What do you mean by catch point?
Okay, so when I was talking about the South Flank movement, and I use the phrase catch point, right? Essentially, when you have a fault's a boundary between two big blocks of land, and the land is moving, one in one direction, the other in the other direction, bounded by this fault. The fault's the slipping surface in between them. And the more a fault moves, the more it gets smoothed out, and the rocks get crunched up, and it gets sometimes powdered, and all kinds of interesting things can happen in there during earthquakes. And but essentially, the fault tries to maintain a surface that can keep moving, right? The thing is, occasionally the rocks are not uniform, and if we talk about, for example, the rocks that make up the volcano of Hawaii, you have surface lava flows, and you also have intrusions and dikes and those kind of things. And if you have a difference in, let's say, the density of some rock, and you have a pocket of denser rock that maybe was an intrusion, then maybe it doesn't grind up or crunch up as easily, right? So when it comes to trying to make that fault move, there's a part of the fault that's a little bumpier. And those bumps in a fault, sometimes are called asperities, those little imperfections in that surface. That's where the pressure is going to build up as the rock tries to move. And when it actually fails, it's gonna fail at that point. So when I say a catch point, it seems like that's the point that seems to be preventing a movement. Being the continuous movement, it is allowing movement, but it's happening episodically through this jerk past that bumpy point on the fault line. Yeah, that's what I mean by a catch point. And I only say that because of the evidence of having seen the magnitude 4.2 and 3.7 and 3.6 and 3.4 all within half a mile of each other, all at the same depth, all during the same era of activity on a rift zone to the north. So that's where I'm coming from with that. All right, so let's turn to the Maunaloa monitoring information here as our last piece before we wrap it up. And so we've covered earthquakes in Maunaloa. We'll look at the tilt. The tilt in the last week is just showing our cyclical variation, small scales here. For the last month, maybe a little more, but nothing beyond what can be believed from what I've shown you guys are natural variations as well. So maybe there is something embedded in there, but it's really hard to pull it out of the noise and the variations, especially just by eye, right? Maybe mathematically you could do it by analyzing the data, but not something I'm going to try or claim to do here. Online live, just looking at it. Looking at the cross-caldera distance change is something that might be pretty localized to that area, to this particular distance, as we mentioned in the past, but still, it's what we have, and interesting to look at. And we can see we're still essentially in neutral. Maybe a continued, very slight extension there, right? But you could argue that that's actually the background rate. Maybe that's background rate right there, right? Something like that. And maybe, looking now at the past 6 months, you see this period between February and early April as perhaps the anomaly rather than the trend, right? So maybe this is a little batch of magma that comes in and causes that adjustment before dropping back down and causing the flanks to move and localized weirdness there, right? The long-term rate might be what we're seeing here. Interesting to consider, and of course, only time gives us the answer to that. But then, if that's the case, then is this also another little pulse right in here, and possibly It seems like we do have this somewhat cyclicity of earthquakes beneath the summit area for some period of time, and earthquakes beneath the flanks, and then beneath the summit, and then beneath the flanks, and then beneath the summit, and beneath the flanks. And similar to that whole cycle, showed you guys from the Walter and Avalon paper, cycles of earthquakes triggering eruptions triggering earthquakes, and how that reveals the cycle of process within the volcano. Really seeing the earthquakes this week, we noted that there are, for the first time since April, flank events occurring. Noted in the update is interesting because we'll just see what happens here next with this GPS line, but the cycles seem to continue on and on and on. And what it tells me, bottom line, is volcano is able to adjust, doing all this with so much action underground without really erupting. And perhaps it's because Kīlauea is moving, perhaps it's because of the south flank of Maunaloa being able to move because of Kīlauea moving, or something else there. It does seem that most of the change recently on Maunaloa, going back to 2002 and intrusion of magma into that rift there, a volume of magma that approaches that we've seen during eruptions, but it came into the volcano and didn't have to erupt at all, and placed underground and moved on to the next year. So that may be what's still happening there. And so there's still a burden of proof remaining for Maunaloa to convince any of us that's just building towards a real eruption, even though we're seeing signs of change of magma coming in and adjusting, and this is moving and that's moving. It's hard to be as convinced about Maunaloa as it is about Kīlauea, because you're not seeing those other changes, right? And in particular, looking at the earthquake rates not being high enough. And we'll wrap it up here with the INSAR. And so this is an exchange here between Dane and USGS. Asked for some more INSAR information from USGS, and USGS obliged on Twitter here and showed a sentinel interferogram from April 16th to May 28th. So month and a half or so. And they're saying the last couple months have been pretty quiet up there and no deformation of note. There are some bands here, but there's atmospheric effects that they're noting in the caption here as well. So that is more information telling us no change at the summit of Maunaloa. And of course, if the flank can move, then it's harder to build up pressure within that shallower area underneath the summit. And so that's kind of the cycle we're stuck in, is moving the flank, building it up some more, moving the flank, building up some more. And at some point, once the south flank locks, perhaps we can build towards a summit eruption, but no sign of that yet. So this is the April 16th, May 28th, and Dane is included on here. The previous release that was for that March period here, with that shallow March earthquake and deformation and inflation, broad inflation in the summit region up in here. So that's that other part of the cycle that we're not seeing now. Okay. Right, so that's the monitoring data we have, and so I'll just end it here by once again thanking Hawaii Tracker, and we do have we are pushing out our new email alert service, right? So you can sign up for our email. It's not exactly a newsletter. When we have certain articles, that we'll send them out by email as well, especially our volcano updates. We do that. So if you'd like to see those updates come in to your inbox, in addition to what you're seeing on our lives and our short video updates and all that, then you can go over to hawaiitracker.com and join your website and submit your email there, and we'd love to send you that. And of course, you can opt out, so just for those interested there. All right, Dane, that wraps up Maunaloa, and we'll do our final things here.
All right, well, we do have a few more questions coming in. We had a $6.99 CA super chat from Boomer, who asks, why are some of the rift zones more active than the others, like the Lower East Rift Zone on Kīlauea or the Maunaloa? What's the most active rift zone on that one? Is it? I want to say it's the south, but I probably got it backwards.
So it's all about which period of time you define for Mauna Loa, right? Mauna Loa, more recently, the Southwest Rift has been active, but long term, the Northeast Rift has been more active. So that's, Mauna Loa is getting big enough that she can pretty much do what she wants. Kīlauea is thought to have that difference in the rift zones because the Southwest Rift Zone is more connected to Mauna Loa, and the Lower East Rift Zone, or the East Rift Zone, is not, right? So the East Rift Zone is more free to move independently of whatever Mauna Loa is doing than the Southwest Rift is. And that's perhaps some of the reason that the Southeast Rift of Kīlauea is more active than the Southwest Rift. Something like that. So quite often, if you imagine, in theory, if you're having a triple junction of tectonic plates on a spherical surface of the Earth, the way you do that geometrically is by having 3 segments at 120 degrees to each other, right? That's how you can break the sphere to allow magma to come up and move the plates, the spherical curved plates across the Earth. Anyways, the point being that theoretically that same process is true in volcanoes coming up through the crust. They want to have 3 different rift zones at 120 degrees, but quite often they're not doing that. They're not coming up into blank space. There's often another volcano already there. So, for example, in the case of Mauna Loa, Hualalai is to its north. So Mauna Loa has a southwest rift zone and a southeast rift zone. And where the north one would go, you get Hualalai, and you get radial vents and that whole sector, right? So Kīlauea also southwest, southeast, and to the north is Mauna Kea. So, and Mauna Loa, depending which angle you go. So those are some of the things involved there, is like what's in place when a volcano is growing, which rift zones are free to move, and that's where the eruptions end up going path of least resistance.
Right. Well, thank you for the super chat, Boomer, on that one. Hope that explains it a little bit. Christina is asking about Mauna Loa as well, and says Phil was showing increased earthquake on the southwest rift zone, like they're around the previous flows, look like the 1950 flows. Is there any connection or coincidence to that?
Coincidence. I mean, those earthquakes are happening a couple miles underground, and just random what's above them on the surface. Yeah.
Right. Let me see if I can get one more. We really haven't gotten all that many questions here today.
Well, it's all good. I mean,
yeah. We'll do this last one here from Daryl, who asks, if things continue as they are, how long will it take for the conditions to be suitable for someone to attempt to descend into the crater? I assume he means Kilauea and Halemaumau here, down to the surface of the lava lake.
Well, if they wanted to bad enough, they could do it already.
I think they could do it already. It's just, there's 2 different questions. Is it possible? And can you get away with it in bureaucracy?
Yeah, is it physically possible?
Yes. Yeah, is it physically possible? I'd say yes. If it's possible within the government constrictions and regulations and everything, and I'd say no.
Yeah,
and not now at least.
And then the question they're probably asking is it worth it? Right. And that's what's the, because okay, maybe there's some risk, maybe like you have to go through a whole bunch of paperwork to do it, but what do you get out of it? Is it worth going through all that? If it's not worth going through all that, then yeah, they're definitely not going.
Right. And we live in a day and age with drones and all the advanced mapping systems, so really you can get a high resolution rendering of it that you can run on your computer without going down there. That would be easier for USGS HVO to conduct and extract and be able to share than trying to actually physically go down there.
Yeah, I've been reading. Maybe I'll end it with this little story here. I've been recently reading about the lava lakes, Makapui. That was the other place besides Kilauea that drilling through the lava lake occurred. Didn't happen nearly as long because Makapui was covered in eruption a few years later. But those guys, they went down there and they note how they're walking on a crust, barely crusted over lava lake, and they're noting how far down the cracks are that they are seeing the lava and the glow, and they're installing essentially a little cable car with a little steel cable the top of the crater down to the bottom, and they're sending down all kinds of drilling equipment and bringing in water and swimming pools, and there's drilling. So not only is it possible, you can actually conduct a whole scientific study on a lava lake already, and that has been done in the past within this time frame, both at Makapui and at Kīlauea. And so if you knew that you'd be able to do that and have it be a long-term study, that you might say that was totally worth it. Of course, both those previous studies happen in different eras of national park management, where it was okay to drill into the active volcano, and perhaps there wasn't as much cultural consultation, I'll say, as well, because that would be an issue today as well.
I'd also say just going down there and attempting to drill. On Kīlauea, you did have that timeline, right? To be able to go down there and drill for a couple years, or what was it, a dozen years that they went down there and conducted that drilling process?
Yeah. 35.
You're not going to get that.
Yeah, 20.
You're not going to get.
Yeah,
you're not going to get that kind of time in the crater in Halemaumau. It's just not going to happen. If it took 3 years from the legendary 2018 eruption until this one, then there's no way you're getting 12 years after this one that we just went through. Like,
yeah,
I'll throw that out right now. That ain't happening.
Yeah.
To do that long-term studies.
For sure, yeah. So you definitely wouldn't expect a long-term study. Even in Makapui data, which essentially was only 2 or 3 years, shows a lot, because it turns out that the fastest rates of cooling are at the very beginning, in the first few years after the eruption ends. So if you knew it was going to be years even, you might say, oh, maybe it's worth trying to get through all of this. But if you think, oh, if we're talking about Kīlauea might erupt again in weeks to months, then what's the point? Because by the time you organize everything to get down there, you're going to have to stop what you're doing because there's something else going to be happening, right? Or adapt to some new condition variable that's changing. So it's kind of too soon. If Kīlauea was all the way completely quiet and not showing the earthquakes and not showing the tilt, not showing the GPS and all that, and maybe you might seriously think about, okay, let's go down there and do some science. But right now, it's kind of catch your breath. There's probably more coming sooner than later. Weeks to months is about the pace of volcanic movement, right? When we see these kind of signals. So that's about where we are.
I know I said one that was the last question, but this question actually piques my interest a little bit. And I never really thought about it. Does magma travel faster underground or above ground?
That's a good question. It's all about the pressure, right? So I mean,
pressure and slope, huh?
Yeah. So it's also complicated by the near surface effects, right? Because when magma is flying out of the ground during an eruption, it's doing so because of the gas. Right, and the gas is building up pressure. The gas doesn't nucleate and form until that last little segment to the surface. So deeper underground, it's not even a factor, right? Because there is gas, but it's all dissolved in the magma. So it's not the same as what if you're imagining like a fountain of lava at the surface and there's magma moving like that underground. It's not, because you don't have that gas effect underground. But you can also imagine that the pathways underground are. I mean, we talk about how they're not really pipes. We describe we've gone from it's like pipes to they're not really like pipes, but in some ways they are fairly constricted areas, right? That can pressurize, and so when you get that, then you can increase your flow rate as well, and in areas like between a summit and the Upper East Rift, if you do move magma through there long enough, you may start to thermally erode and physically erode those pathways and widen the gap, like the conduit, and then you can also get away with an increased flux through there. Yeah, that's my instinct there in the answer. Of course, we're just discussing right now. I'm not an expert in that. Just a best guess.
Makes sense. Do want to shout out that we are going to be releasing another episode of Drones On May 24th and 25th of the 2018 eruption. Going to recap some of the activity as it really just, that was a bad day in Leilani Estates, that one. This episode is not a friendly episode, but we also go through some of the things that the people on the ground were doing, that were trying to help everybody else that were going through the pretty traumatic days that the 24th and 25th represent. and it isn't going to get any easier in the next episode either. But yeah, that's where we are in it. So come check it out. It's only 9 minutes or so, this one. So not that long, but definitely tries to give a little bit of different context to the eruption from the ground and from the people that were living it. So hope to see you guys there, and we will be premiering that right after this live stream.
Right on. And maybe one more thing, Dane. There was a question that came in last week in our YouTube chat. People are wondering, what is Leilani like now, right? Someone was asking, are the roads open? Are there still barricades? Can you, are people living there? Was even part of the question. How would you summarize what's going on?
So everywhere that wasn't consumed with lava, except for 5 houses in Leilani Estates, is essentially occupiable. You can go back. There's a couple places, like a very few select places that are right near where the gas vents, and it's kind of, people still live there though. I mean, I know guys that are living right with the gas vent, right in their front yard. They're still happy with it. In terms of the vegetation, it's overgrown now, and it's not kind of what I was expecting. The weed trees really just filled the void that was left from all the SO2 after the eruption. That wasn't something I was really ready for. I was kind of hoping all the native plants are more resilient and they'll bounce back, but a lot of these invasives just really popped up and have been taking over certain areas that they maybe were less dominant in before. But yeah, it's inhabitable. Some of the jungle is still somewhat dead, the parts by Fisher 8, but yeah, it's interesting. The real trip to me is how overgrown the roads that were closed are, right? So like Kahukai Street going towards the Poiki, they put the barrier up there immediately after the eruption, and there's like a half block of road left. There's no houses down there, and only a couple people go walking down there. So the entire road, everything is overgrown, and you can't even tell there's a road there really. And it was, a full road. You can't even tell there was a road there except for one little walking path that just zigzags through the bush all the way down there.
That's at the Y, yeah.
No, that one's Leilani.
Leilani, okay.
Yeah. So the north side of Leilani, trying to make it across
the
lava channel. Yeah, down there. So there's a few places like that. It's just crazy how fast the vegetation can grow in Puna.
Right. And the roads are all essentially back open again. There's no police presence. There's no barricades. This neighborhood watch is in effect.
And they left up some barricades, some guardrails and stuff like that, and just left after the eruption. And then really probably half of them have been tampered with or removed at this point by people that just want to get back to their property and are done waiting for the county or anybody else to, give them permission to return to their house. They're just,
right,
gonna get out there and make it happen.
Right. So it's in the hands of the residents now, and they are back. Yeah. So mahalo, Dane. Check out Drones On here coming up right after this on YouTube premiering live. Mahalo, everyone. We'll be back with you guys next week, Thursday. And until then, he's Dan DuPont. I'm Philip Ong.